Now we want to do multiplication and division with rational expressions, and as you'll see, the major step really is very similar to reducing rational expressions to lowest terms. Here it says multiply or divide as indicated. So if it's multiplication, I'm going to multiply. If this was division, I would divide. I have this rational expression times this rational expression. When I multiply numerators and multiply denominators. But I'm not actually going to multiply because in the next step I would have to factor in order to try to reduce to lowest terms. So instead what I'm going to do is just simply show the multiplication like this. So here I've multiplied the numerators, that's this. I've multiplied the denominators, that's this. Now I want to factor. Let's take the x cubed out in front. 2x plus 10, I'll factor out a 2. What's left is x plus 5. In the denominator I have x squared. And here I can factor out a 4, and what's left is x plus 5. Now, I look for factors common to the numerator and denominator. X cubed is x squared times x, so I'll divide that x squared out with 2 of the factors of x that are in this 3 factors of x here. There's a 2 common to the numerator and denominator, so I'll divide that 2 out, and then x plus 5 common to the numerator and denominator. So what I have left after I've reduced this to lowest terms is an x in the numerator and a 2 in the denominator. So that complicated expression here, this product right here, simply ends up to be x over 2 when I multiply and then reduce to lowest terms. So as you can see, when I multiply, I don't actually multiply out the numerators. I simply write them together like this, then I factor and divide out any factors that are in common. Our next problem is a division problem. I want to take this rational expression and divide by this rational expression. Well, as you know, division is multiplication by the reciprocal. So I'll just write my first rational expression here, and then I'm going to change division to multiplication by the reciprocal. So y plus 2 will go in the numerator and 2y minus 6 in the denominator. Now it's a multiplication problem. This rational expression times this rational expression. Well, I know I'm going to multiply numerators and multiply denominators, then I'm going to factor and reduce to lowest terms. So I'm going to do the multiplication and the factoring at the same time. First I'll factor this polynomial into y minus 3 times y minus 2. This y plus 2 can't be factored any further, so I'll write it down just as one product here. Now I go to this polynomial or binomial here, I'll factor out a 2. 2 times y plus 2. And then I go to this one and I factor a 2 out of it, and what I have left is y minus 3. Now I look for factors common to the numerator and denominator. I say I have a y minus 3, that will divide out. A y plus 2, that will divide out. And then let's see, in the numerator I have left y minus 2, and in the denominator I have 2 times 2, which is 4. So that is the quotient right there of these two rational expressions. So I see I have division, I change to multiplication by the reciprocal. Now when I multiply and factor at the same time. So I saved one step in this problem that I showed in the first problem. Let's try another one of these. Here's another division problem. I'm going to have to multiply by the reciprocal, then I'm going to factor and then reduce to lowest terms. Let's try everything at once in this one. I'll start by factoring this numerator into 2y minus 3 quantity squared, but let's just write it as 2y minus 3 times 2y minus 3. Now I'm going to multiply by this, so now this will be in the numerator and this will be in the denominator. So let's factor this and write it in the numerator. Y plus 6, y minus 1. Now this factors into y plus 6, y minus 6, and that what was in the numerator now will be in the denominator when I change division to multiplication by the reciprocal. So let's factor this into, let's see, 2y and y. And if I try a 3 and a 1, no, let's do 3 and 1 like this. I'll make them both negative. Does that work? 3y and then 2y, add up to 5y, and they're both negative, so negative 5y. Okay, so you see I've done 3 steps really in one step right here. I've changed division to multiplication by the reciprocal, and I've done my factoring. These factors right here are the factors of what was in the denominator, which will now be in the numerator when I change to multiplication. Likewise, these factors right here that are in the denominator came from what was in the numerator, which will end up in the denominator when I change division to multiplication by the reciprocal. All we have left to do now is to divide out common factors. Let's see, here's a 2y minus 3 and a 2y minus 3. Let's divide those out. Another 2y minus 3, I don't see any other ones. A y plus 6, there's one of those. And then a y minus 1 and a y minus 1. Those divide out. What's left in the numerator is 2y minus 3, and in the denominator, y minus 6. So there's the reduced version of this quotient right here. Now, one last problem I want to show is a multiplication problem. It sometimes throws people. It's actually simpler than any of the ones we've done so far. X squared minus 9 times 2 over x plus 3. Well, this right here, this polynomial, is actually a rational expression with a denominator of 1. Now you can see it's going to be easy. I'll simply multiply this numerator times this numerator, factor at the same time, x plus 3, x minus 3, times 2. All that's divided by 1 times x plus 3. You see my x plus 3's will divide out, and what I have left is 2 times x minus 3. And if you want to multiply that out, you can. 2x minus either answer would be fine on a test in my class. So the important thing that you see here is that x squared minus 9 by itself can be considered a expression with a denominator of 1. So that's how we do multiplication and division with rational expressions.